So notice here, I don't specify whether it's degree or radian. The degree symbol here does specify its degree. If there's no degree symbol, you assume that it's radian.
Okay.
Now in that picture I gave you earlier, and then the reference sheet you got here is both 0 degrees and 0 radians. So it's not really that I'm asking you to do anything odd. It's just, I want to point that out here. If it's got the degree symbol, it is absolutely degree. If not, it is radian.
Okay.
So give this one a try here. Tangent is y over x.
Would it be 1/1? Just one?
Or for tangent or for sine or for both together?
For both together.
So the final answer, I agree, is 1 here. Tangent is really sine. I'm just going to do this in case you want to look at this later. Sine is 0 over cosine is 0, which ends up being 0 over 1. And that's okay. Sine of 90 is 1. So this becomes just 1 like that. Okay. Let's do one more here. Let's say it's 1 over sine pi over 6 plus 2 over cosine pi over 3. Take a look at that. Let me know if you have any questions.
Mm. So I got 1 over root of 3 over 2 plus 2
So
over.
keep in mind here that y is the sine value. So this first one should be 1 over 1/2. Yeah. You're like, man, this guy's cruel. He's giving me a hard problem to start out. I was just wanted to see if you could handle the fractions here. If you noticed, I've been trying to avoid the roots with the squares, and that's what they tend to do on the exams. They don't tend to make you have roots in your answer, but and x is the cosine value.
So just be 1/2 for both of them.
So 1 divided by 1/2, you have to multiply by the reciprocal, 2 over 1 on the top and bottom here. So on the top, you can rewrite 1 as 1 over 1. And then on the bottom here, everything cancels out. The 1's cancel, the 2's cancel, but in the numerator there, you've got 1 times 2, 1 times 1. So it ends up being just 2 divided by 1 there.
Okay.
Or 2. On the right here, cosine of pi over 3 is also 1/2. And then you're going to do the same thing here now. Oops. So the same thing, you're going to multiply by the reciprocal. So it's times 2 over 1 times 2 over 1 like that. You can treat the 2 in the numerator as being over 1. And again, in the bottom here, everything just cancels, but the numerator becomes 4, 2 plus 4, like that, or 4 over 1, if you will.
Okay.
All right, so here is where we're going with these problems. These are other things you might see on standardized tests. So you need to know some triangles, okay? You don't need to know everything about triangles, but do you remember anything from geometry class about triangles or anything, formulas, anything like that?
To find the sides of triangles, it'd be a squared plus b squared equals c squared.
Perfect, perfect. And let's just start with that. You have to know that. I don't think it's given. I mean, even if it is, I mean, you already know it. How does that apply here? So in a right triangle, okay, A, B, and C, A and B are the legs. The legs come out from the 90. And then the C is the hypotenuse. And you know this, but this is just for review here. So, why would I be doing that? Well, you may get a problem like this, where they give you two of the three sides, and they ask you to find the third side here. So this would be 3 squared plus 4 squared equals c squared. Can you tell me what c is in this problem?
Five.
It is 5. Very good. Now you may remember there are several triangles that are nice, meaning the numbers are generally whole numbers on the three sides. These are the kinds of problems you'll see in standardized testing, because they don't really want to mix in the roots here. Now, let's just say I gave you this triangle here. Just redraw it here slightly so we can snip this in. There we go. And let's say I labeled this angle A. I know A really goes in there, but it's better if you kind of see it as on the vertex there. Do you remember from your geometry class sine A, cosine A, tangent A? Do you remember any way to remember how to find this relationship, sine, cosine, and tangent?
For sine, it's opposite over hypotenuse.
Good.
Cosine is adjacent over hypotenuse.
Very good. Opposite over hypotenuse. Keep going here. What about cosine? I'm sorry, what about tangent?
Opposite over adjacent.
Perfect. Now, relative to this angle A, can you give me these three fractions, please?
Sine A is 4 over 3. No, 4 over 5.
Good. Very good.
Yep. Cosine is 3 over 5.
Keep going.
Tangent is 4 over 3.
Very good. Okay. Awesome. Okay. So here's just kind of a basic question that you might get, okay, on a standardized test. So they might give you a triangle like this, and they might tell you that this is 10, this is 6, and this is X, or they might not even label that, but they might ask you for the cosine of A. Okay. So to find this, you have to first determine the value of X, then use it in the cosine formula. Okay, so it's kind of, it's always a synthesis or a combination. It's right. It's like, first you've got to use Pythagorean theorem, a squared plus b squared equals c squared. Then you got to know your trigonometric formula, sine, cosine, and tangent here. Can you visually tell me the value of X? It is related to the one we just did, but it's a little bit different type of problem. So I don't want to presume you know that. If not, can you please use a squared and b squared equals c squared to get the value of X here, please?
I don't know it, so I'll just use the formula.
Okay.
Is X 8?
It is. It is. So now let me go back and talk about that for a moment. So remember how this was 3, 4, 5? And this previous problem was 6, 8, 10. So there's these triangles. They're called Pythagorean triples. And the way they work is you can actually multiply or divide all three sides by the same value. So in this case, we multiplied by 2 to get a new triple, or you could multiply by like 3, 9, 12, 15, or any number of values. Okay. So this is one of those things where it's like, well, if you knew these triples, it could save you time because you didn't have to do this calculation.
Mhm.
And so like students who get the best scores on these, they know some of these things. They know which ones to say. They're like, okay, I need to know this triple. There's a few others I'll write down, but you need to know them to save time, not because they're important, but because they help you save time. Because once you know this is 8, cosine of A is 8 over 10 or 4/5. And that is your final answer here.
Mhm.
Okay. So let's look at another problem here, if that's okay. So this would be more, we're kind of gradually getting closer to like what would a standardized test question look like here. So let me give you another triple here. This one is a triple. And let's call this A and B. And again, getting closer to what you might actually expect. What is the cosine of B plus the cosine of A? Right. So notice you already have the cosine of B, right? That's 5 over 13,
Mhm.
but you don't have A, which means you're going to have to find that third side, and then whatever that is, add it to this.
The missing side is 12.
Good. Yeah. So that's another triple. I'll give you a list here shortly. So
Okay.
what is the cosine of A in this problem?
12 over 13.
12 over 13. Good. Now, when you add these two, they get 17 over 13. I believe they still mostly use improper fractions on this, so you wouldn't want to simplify that at all. But really good, really good here. Let's try another one here. So I'll give you another triple that you might need to know. And let's go 8, 17. We'll call this B. And we want to find A. I want you to find 1. Oh, I gotta be careful here. Let's just go 1 plus the sine of A. 1 plus the sine of A.
On the missing side is 15.
Yes, good. Okay, so keep going there.
It'd be 32 over 17 or.
Good. That sounds correct. Yep,
Okay.
32 over 17. Good. Okay. Now, unfortunately, like I don't know every possible question or thing that they could answer. So when we do problems like this, like keep in mind, like I'm just sort of leading you towards the path. Like you need to know how to find the third side of the triangle, which you now know, or you know already. You need to know, sine, cosine, and tangent. Okay. And so these problems lead you to do, something else, something maybe that you've never seen before that might appear on these tests. All right. So I've got a couple other problems here from another student here. Give me just a moment here to pull them up. Fortunately, the brain doesn't just realized I had these, of course, instead of giving these to you. All right, let's try. Oh, these are all. Yeah, this is a good one. Okay, so here's another question here. Maybe we'll do a couple more and then we'll switch topics here. I like to do a couple of topics every time with you. So it's just find X, Y, and Z. So this is not a standardized test question, but it's very much like what we've been working on. Okay, the standardized test question might actually ask you to find something like the area or the perimeter where you have to find all these intermediate values. You want to focus on finding this value on the left here. So now let me give you the Pythagorean triples because they do apply to this problem here. So there's 3, 4, and 5, 5, 12, 13. And just keep in mind, these are in the order of leg, hypotenuse. They have to be in that order there. 8, 15, 17, 7, 24, 25. Yes. Okay. And these are basically in the order of like, if you could only remember one, you'd want to remember the first one. If you only remember two, you'd want to, and so on. Like this list actually goes on forever, but you don't need to remember them all. Just remember a couple here. Could save you some time here. I believe these both apply to this problem. So the way this works is if you think that it's a triple, like let's say you think that 20 is really the 5 side and 12 is maybe the 4 or the 3 side, you'd say to yourself, well, what do you multiply 5 by to get to 20? And that's 4.
4.
Right. And then it's like, well, does that work for the 4? No, it doesn't work for the 4, but it works for the 3. Like if this is the 3 side, 3 times 4 is 12 and 5 times 4 is 20, making X what value?
12 or no.
So this is the 5 side, this is the 3 side, and this is the 4 side. Sometimes that's helpful to do, to label them like that.
Okay.
What would X be?
16.
16, good. So so now, you almost have to restart here with the 9, 12, and the Z. What would Z be in this problem? This one is a 3, 4, 5, by the way, on the right.
Okay. It would be I need some help on that.
Okay. So one of the things you can do here is redraw the triangle. So like this is that blue triangle, just to take your focus off of everything else that's going on in the problem. So this is 9, 12, and Z. And just like before, it's like, okay, well, it kind of looks like a 3, 4, 5. Maybe you're trying with the 12. It is a 3, 4, 5. It's like, well, how do you go from 3 to 12? Well, you multiply by 4. But does that work with the 4? Does 4 times 4 get you to 9? No. So maybe you've got them flipped. Like maybe the 9 is really the 3 side and the 12 is really the 4 side. 3 times 3 is 9. 4 times 3 is 12. We've got it. So Z is is 15.
Okay.
Okay. Now you can always fall back on Pythagorean theorem. It's just slower. And there's nothing wrong with it. It's just that on these tests, you really want to speed up your time through the exams. Okay. So this problem, this is not a standard question the way it'd be written. It would say something like, what is the perimeter? And it might say of triangle S, or you're doing the ACT. They actually like doing, what is the perimeter of ACT? So you'd have to find the missing values and then add them up. That would be kind of your standardized test question.
Okay.
All right, so here's what I'd like to do. I do teach a class on this stuff, and I'd like to pull up my class 1 materials. It's questions though. It's not like me like lecturing at you like you get in the classroom. That wouldn't be very helpful. We're going to talk though about a test taking strategy. Have you talked about have you seen test taking strategy stuff before?
Not much.
Not much. Okay. Now, a lot of the stuff I've got is towards the SAT, but it applies to the ACT. There's a few subtle differences. One is there's 5 answers in yours. Okay. But I want to first talk to you about the structure of questions, because I think this is really important for you to know that they're always the same. Okay. So the first thing is that there's always what I call a prompt. Okay. And a prompt is some sort of given information, like it's an equation, it's a figure, it's maybe a block of text. Okay. It's something that's at the top of the question. And then there's always what I call a call to action. This is what actually tells you like what you're supposed to do. And sometimes this is unrelated to the prompt. Like there's obviously distractions where they're trying to get you to read through all this stuff. But there's always a call to action. It's typically the last sentence. Okay. Then there's also the answer space. And for you, I believe it's all multiple choice, but some problems there are free response. Okay. And so for this time here, I want us to talk about the strategy, which is to read this call to action first. Okay. So let me go ahead and show you a problem here and tell you what I mean by that here. So we want to read the call to action first. All right, so I'm gonna highlight that. It says, what is M when L is 73? The reason you want to do this first is that it tells you what to do often.
Mhm.
Like your eyes are already drawn to this equation, but if you read this sentence first, it tells you, oh, I need to put 73 into this equation and solve for M. You don't need to read the rest of this. You don't need to know that one end of a spring is attached to a ceiling when an object of mass M, blah, 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 right? You have to go right to the thing that it's asking for. Okay, so in this case, what is M when L is 73? 73 equals 24 plus 3.5 M. And you don't care about anything else. You don't need to know that it's mass M in kilograms, centimeters. Like, this is why it's so important to read the call to action first, because it tells you where you're going. It's like getting in your car and not knowing where you're driving to. You got to know where you're going before you start. So could you solve this for M for us, please?
Okay. Would it be M is 14?
Yes, that is correct. Very good. All right. So read the call to action first. Okay. And let's look at another problem here where it's really important that you read the call to action first. Okay. And this takes a little while for your eyes to be trained to do this, but because I'm teach the stuff and I've seen this for a long time. I know right to go right to that. Even if I'm reading something else, I always go right to the last sentence because I want to know what it is that they're asking for here. Okay. So this problem, it says, what is P in terms of T? What is P in terms of T? That literally means to solve for P. You're gonna take this equation and you're gonna solve for P. You don't need to know anything else. You don't need to know that it's at a store code originally priced at P dollars. And I know we're taught like, hey, start up here, don't jump to the end. Fortunately, that doesn't really help you when you do this. It takes too much time to read it. So we will get to like answer space problems. We can do that in another lesson. But basically, you have to solve this equation for P, which means you're going to divide both sides by 0.8. And the P's the 0.8's cancel. Can you look at the answers now and tell me which of these matches what P is?
D.
Letter D. Now, I don't know that this is correct in terms of like what would actually be allowed on the stairs. I think they would maybe want you to reduce this. So 0.8 is 4/5. Remember how we talked about multiplying by a reciprocal earlier?
Mm-hmm.
I actually think that if this were on the test, and they don't release the test, they want to keep those things in the lockbox there. But I would think it'd be something more like this as your answer. So you want to be comfortable with moving between decimals and fractions. That's a skill we can do at some point here. All right.
Okay.
Okay. I want you to try this approach on a new problem. Okay. So I really want you to try to avoid reading it. I want you to just go right to the last sentence, read that, and then use that information to solve this problem, please.
Okay. The volume is 36.
Yeah. And that took you like 15 seconds. Okay.
Mm-hmm.
How much longer would it take you to read?
Probably like a few more seconds to read it.
Yeah. Now, do you like reading? Are you English books, personal reading? Where do you kind of stand on that?
I don't really like reading at all.
Okay. Good answer. A lot of these questions are story questions or word problems. They're not necessarily like the traditional word problems where it's like a train is moving this direction or, car starts out. They are filled with information. A lot of it is not needed. A lot of it's useless, truthfully. And maybe you've never heard that before. And you're like, wow, like it really is. This problem really is about your ability to start here. Okay. Now, this technique, I handpicked these. Like these problems are handpicked to like show you that you can read the last sentence first, but it doesn't always work out where that is everything. Okay, so you start by reading the last sentence, but then you have to decide, do I really need to go back up and read the rest of the problem? Okay. And you'll see in the next one here, you do in fact read the last sentence. It says, what does 12 represent in the equation? And there's your equation, but I don't really know what it is. It's the y-intercept, but if you look at the answers here, there's no y-intercept. So this is the case where you read this first, but then you go back here. Now here's why you do that. When you read a question and you don't know the answer, the way the brain works, this is my understanding of it, is it's trying to solve that problem. So when you read this, you're like, what is 12? You're like, I don't know, 12. But somehow your brain knows when you start reading this, my brain too, everyone's brain, you look for it. You kind of like, okay, it's there. You start like trying to piece it together. Okay. A person wants to purchase tickets from a vendor to watch a tennis match. By the way, you'll notice I don't actually read the words because they often slow you down. You just say S wants to purchase tickets from a vendor. The vendor charges a one-time service fee for processing the purchase of the tickets. The equation T equals 15n plus 12 represents the total amount. T in dollars S will pay for N tickets. Okay, so 12 is the one-time service fee. So now you got to go to the answers and figure out which one matches them up. So you start reading the call to action, then you go back and read the prompt, then you read the call to action again. And hopefully that's enough to figure it out here. So can you tell me the correct answer for this, please?
B.
It is B. Okay. So I'd like you to try this approach with the next problem here. Okay, I'd like you to first read the call to action, then go back and read the prompt and see if you can figure out the answer from there. You are allowed to use a calculator. I'm not anti-calculator if you think it'll help, but try the technique we're using here, please.
Okay. Would the answer be A?
A. Tell me how you got A. What did you do to find A?
It said like what's the closest to the percentage of the people who rated 5, and so I looked at the numbers and how many people rated 5, and
And
only
how many rated 5 here?
2 people.
Okay, out of
10. Oh no, yeah, no. What? 11 people.
yes. So you start by reading the call to action, and then you go back. And you might have missed that. It does say 11. I heard you counting. No big deal there. And then if you need to use your calculator, right? What is 2 divided by 11?
0.18181.
Yeah.
Repeating.
Yeah. So like another way you could have done this is said, well, if I multiply by 9, that gets me to 99, and that's 18. The correct answer is B. I've given this problem to, I don't know, say 50 students, and the most common answer is A, and I'm still trying to figure that one out. Why do you think that is the one that you chose here? Because your work was correct. Just really curious if you have any insights there for me.
Just because it was the lowest number. So
Got it. Yeah. Okay. So there's another kind of thing going on in this question, which is you actually don't need a calculator because you can estimate the answers, and they're far enough apart that not a big deal to guess one. Like, you're not going to get them so close that you're going to wish you had done that. So here is another question for us to look at. So here's what I want you to do this time. I want you to spend 60 seconds working this out. Try and use the technique we've been talking about. You're welcome to use a calculator, but don't give me your answer. Just hold on to your answer. Just let me know when you're all done. But take at least 60 seconds here to see what you come up with, please.
Okay. I'm done.
All right, so here you go. Good. That was within the time limit. You want to take about 60 seconds or less per problem. We can also kind of talk about a strategy for that as well. So this one says, what was the mean low temperature in degrees Fahrenheit during the 5-day period? So a couple of keywords there: low temperature, 5-day period. So we're looking exclusively at this one right here. Now, when I just scan the data, 49, 37, 41, 54, 63, does any of these answers jump out or stand out? And I'm like, well, not really. So this one you kind of do have to add up to get the right answer. So to find the average, you add the numbers up: 49 plus 37 plus 41 plus 54 plus 63 over 5. Now, what you might notice is that 49 and 41 go really well together. That's 90. 37 and 63 go really well together. That's 100. Okay. Plus the 41, but you're still kind of going to have to go to the calculator on this one. So what did you come up with for your mean low temperature? Or did you do something different than this?
I just added up all the numbers and divided them by 5.
Okay, so did you get
and
A,
then
B,
got
C, or
that
D?
I got A.
Excellent, excellent. Sorry for interrupting you there. Excellent,
No,
that's
you're fine.
awesome. Okay, so sometimes you're not necessarily saving time in the calculation here, but you know where to go. Like if you read this from top to bottom, you might get the table below shows the high and low temperatures in Houston, Texas. Some people get distracted. They're like, oh, I wonder what Houston's. Oh, that's pretty nice this time of year, and they're, oh man, it's Friday. I wish it was Saturday. Like there's a lot of ways to get distracted and not just do the problem. And that's why I like going to this call to action first, so you know what you were trying to find here. All right, let's try another one here. I'm pulling these questions from all different areas of the test. So we'll do more specific math practice, each time, kind of like we did in the beginning. But why don't you take a look at this question again? Read that last sentence first, and see if you can come up with the right answer here.
I'm done.
Excellent. What is your correct answer on this?
C.
C. Very good. Any questions on that?
Mm-mm.
Good. All right. So one of the things I do in the class that very important here is, and I'm going to ask you this question, is does this strategy always work? What do you think? How would you
I
answer
think it
that?
works.
It does work, absolutely. But it doesn't always work. There's not like okay, if I just read the last sentence every time, like that's like sometimes we get into those patterns because the way our brains work, the way we do things in life is like you keep doing things that work. Like if it works, you just do it over and over again. I'm going to give you an example here where it does not work. And this is not to suggest that you shouldn't use the strategy. It's to suggest that you should be very, very careful when you use any strategy on these tests, knowing when to use it and why here. So this problem says, what is the probability to the nearest hundredth of selecting a school in San Diego County? Well, here's San Diego County. There's 854 out of 3,241, because that's the total there. Could you divide these for us, please?
Um, 4,095.
Dividing, right? 854 divided.
Divide.
Yeah, sorry, maybe I'm unclear there. Please divide.
I
Yeah.
clicked the wrong thing. 0.26349.
Okay. Is that answer here?
No.
It's kind of C, right? But it's not. One thing you should know is that the answers are never that much off. Like you might think that they're really close, they're not. So the good thing here is that even though this is wrong, this is not right, the answer isn't there, which is good. Okay.
Mhm.
But I mentioned like this strategy does not always work. Let's go back and read the previous sentence. A public middle school will be selected at random. Now that's really important information actually, because what that does is it actually says it's this row, not all the San Diego schools. But do you see how if you just read the last sentence, you can choose the wrong one? Now, thankfully it didn't work, okay? But that's why this strategy doesn't always work. Like there is information sometimes encoded in the rest of the problem that you have to take there. So the public middle schools, the one from San Diego is 165 out of 587. Would you calculate that for us, please?
Zero 0.281.
Yeah. Yeah. So like you might have gotten away with like doing this and then guessing that, but if it were me writing the question, I would have put the wrong, I would have made these numbers so that it wasn't correct, or it was here, but it wasn't correct. So you got to keep in mind, you got to read the full question here, read the full question. So the strategy works really well as a starting point, but no guarantee that it's going to work for everything. So let's, I think we got time here for one more problem here. Okay, so let's use the strategy we've been talking about. What was the highest score? Okay, you might think, well, 36 is the highest score. I'm done. But it's never that simple. I mean, and I think students do that. I think that's why it's here. Okay, now it might be that the answer is D, but not for that reason. So let's go back and look. The mean score of 8 players in a basketball game was 14.5 points. If the highest individual score is removed, the mean score of the remaining 7 players becomes 12. What was the highest score? Okay, so a lot of times when you're working with averages, you actually work with sums instead of averages. So what I mean by that is 8 times 14.5, that's your sum, that's 116, and 116 divided by 8 is the 14.5, but we're removing one of the scores, okay? And we remove one of the scores, it's 7 times the new average, 12, that's 84, and the difference here is 32. Okay. So this strategy works a lot. Okay, don't think that this strategy that we talked today doesn't work. It's really a good one to start with. Always read the last sentence first. It typically only applies to story problems. Okay, so keep that in mind. Like, you know, if it just says to solve, there's nothing to read. But because it's a story problem, read the last sentence first, the call to action, then go back and see what else you need before that. So this leads into what I call the next test taking strategy, which is the which of the following. And that's one of the most common questions you'll see on the exam. So we'll talk about that next time, whenever that is, but we do have to stop here for today.